for this unit, we have to remember some Algebra 1 topics. So I'm going to go through this video and I'm going to explain some of them in each of these sections. The three sections, the first two are on the front, simplifying polynomials and factoring polynomials. And then on the back is actually solving. You have to be able to use Algebra 1, this type of Algebra 1 in our circles unit, which is why I'm going to take some time to go over it. If there's a specific section you don't need to review and you remember, you're welcome to skip over parts of this video. So with the first section, simplifying polynomials, all I'm going to do is distribute. Okay? So if I take a look at number 1, I'm just going to distribute 2x to everything. So 2x, I should say distribute and then COT, combine like terms if possible. So when I distribute, 2x times x is 2x squared, because x times x is x squared, you have the exponents. And 2x times negative 3 is negative 6x. Am I able to combine these terms? No. So I'm done. If I look at the next one, I'm going to distribute. So 3 times 2 is 6, and y squared make y cubed. 3y and negative 5x, 3 and negative 5 make negative 15. Y times x is just yx or xy. Typically you have it in ABC order. And then 3y times 2 is just going to be 6y. I can't combine any of my terms because the two terms I just underlined don't have the same degree. They both have a power. This one has an exponent of 3 and this one does not. And I also cannot add y with xy because one has an x and one doesn't, so I'm finished. So I'm going to skip number 3 for you to do on your own. Let's jump down and talk about number 4. Notice number 4, I have two sets of parentheses. So how do I distribute a problem like this? Well, this is where I would double distribute, or I would use the word FOIL, depending on which word you learned in algebra. FOIL stands for first, outside, inside, last. I just double distribute. I see x, and I distribute it to everybody in here. X times x is x squared, and x times 3 is 3x. I distributed x to everybody, and now I'm going to distribute negative 2 to everybody. So negative 2 times x is negative 2x, and negative 2 times 3 is negative 6. I'm now going to look at the middle terms because I can combine them, and that makes 1x. So x squared minus x minus 6, and I'm finished. If we go ahead and we do number 5 together, I know I have to double distribute because I have two sets of parentheses. So 2x times x is 2x squared. 2x times negative 1 is negative 2x. 1 times x is x. And 1 times negative 1 is negative 1. Clean up my middle terms. 2x squared minus x minus 1. And I'm done. Number 6, I always call it the gotcha problem. It's trying to trick you. 3x plus 1 squared, you're going to think you can distribute that exponent inside, when in reality you can't because of that plus sign. When you have two terms inside of a parenthesis, you have to scribble out that and you have to write it again. So it's really saying 3x plus 1 times 3x plus 1, which now, because I have two sets of parentheses, I have to double distribute. So you can go ahead and you can do those problems on your own. The two I did not do. I'm going to go ahead and I'm going to move down. Let's go ahead and let's talk about factoring polynomials. Factoring polynomials you're really good at when you first learn it. It takes some practice. Every teacher teaches factoring different. So if you remember how your Algebra 1 teacher taught it last year, you're welcome to do it that way. I'm going to show you the way that most of us teach it, but there are a few different methods. So when you're factoring polynomials, that means to get answer in parentheses. So my goal is to be able to undo distributing. So all the problems that I did in the first section, I'm now trying to undo it. So, and I'm going to end them with parentheses. So I'm always going to start with the same spot. I'm going to always start by asking myself the same question. Is there A, G, C, F? That can go in one of two ways. You can either say yes, there is, or no, there's not. If there is, you're going to take it out. How do you take it out is you just divide every term by that GCF, and then you would stick it on the outside of the parentheses. If you say no, then you're going to do what we call the X method, which you all start to remember very quickly. If you say yes, there is a GCF, you're going to take it out, and then you have to go one step further and then do the X method again. I am only able to do the X method if I have the biggest exponent is 2. If I have an exponent of 3, 4, 5, 12, I can't do the exponent. If I don't even have an exponent of 2, I can't even do the X method at all. Let's go ahead and let's look at number 1. I'm going to kind of skip around on some of these problems. If I take a look at number 1, first question, is there a GCF? GCF stands for greatest common factor. Is there a greatest common factor between 2x squared and 8x? Well, they both have a 2 in common. What else do they have in common? They also have an x in common. So I'm now going to, I write the GCF on the outside. I'm now going to open up a parenthesis. I'm now going to take it out by dividing. What's 2x squared divided by 2x? Well, it's just x. And then I have a plus sign because it's plus. What's 8x divided by 2x? Well, that's just 4. I can't do the X method with my leftovers like this step says right here because I no longer have a squared variable. Notice that's all singular. Okay? If I go ahead and I look at number 2, notice does not have a GCF. Look, x squared, 10x, and 9, they have nothing in common other than 1. So now I'm going to do the X method. So remember when you do the X method, your last number goes on top and your middle number goes on the bottom. I now need to think about two numbers that multiply to get you 9, but at the same time add up to get you 10. What are they? Well, 9 and 1 make 10. I'm sorry, 9 and 1 make 10, and they multiply to get me 9, but I want negative 10, so both of them would have to be negative. So these are my answers. So I have x minus 9 and x minus 1 because they're both negative, and I'm done. And if I wanted to check my answer, I would just double distribute. I'm going to skip 3 for right now. Let's go down and let's look at number 4. Number 4, first thing you always want to ask yourself, is there a GCF? There is not a GCF, and I know there's not a GCF because I have no leading coefficient. My y squared doesn't have a number next to it, so that's kind of like a trick. So I'm going to do the X method. My last number goes on top. My middle number goes on the bottom. I need two numbers that multiply to get you 6, but at the same time add up to get you 5. 3 and 2. Circle. Now I have y plus 3, and I have y plus 2. And I'm done. If we go over to number 5, and we look at number 5, first question, is there a GCF? Yes, they all have a 2 in common. So I'm going to take out a 2. So I'm left with a squared plus 11a plus 9. All I'm doing is dividing each term by 2. So now because I still have a squared, I have to do the X method. So last number goes on top, middle number goes on bottom. Factors of 9 that make 11. 3 and 3, no, 9 and 1. Nope. So no factors work, which means I can't do the X method. So this would be my answer. If I go ahead and I look at number 3, if I do the X method here, 24 goes on top, negative 4 goes on the bottom. I know I don't have a GCF, and I know the trick to that because I have no leading coefficient. So factors of 24 that make negative 4. So 12 and 2, that doesn't work. What about 8 and 3? That doesn't work. 6 and 4? That doesn't work. What about 1 and 24? That also doesn't work. So I can't factor it. So if I can't factor this, this would be unfactorable. Okay? If we go down and we look at number 6, number 6 is the mean question. Because notice, do I have a GCF? No. But I do have a leading coefficient, so my X method just got a little bit harder. So whenever I have a leading coefficient, I have to slide it to the back number. 3 times negative 5 is negative 15. And then my middle number still goes on the bottom, negative 2. Factors of negative 15 that make negative 2, negative 5, and 3. Before I got to circle these, but now I'm not allowed to. I have to factor by grouping. So I'm going to write 3p squared, and then I'm going to write any of those. I'm going to do negative 5p plus 3p, and then minus 5. So now that I'm here, I have to factor by grouping. So I have 4 variables. I split it down the middle. So you always split it 2 terms on the left, 2 terms on the right. Now you're going to take out a GCF on that side. The left side has a p in common, so I'm left with 3p minus 5. Notice this side. Do they have anything in common? No, so I'm just going to take out a 1, so I'm left with 3p minus 5. See how my parentheses match? That's one answer. And then my leftovers make my other answer. And I'm done. If I wanted to check my answer, I would double distribute or FOIL to check. All right, so let's go ahead and let's try again. Again, this problem was mean. You have to factor by grouping when you have a leading coefficient and not a GCF. So like if I look at number 7, I don't have a GCF, but because I have a leading coefficient, I have to factor by grouping. So I'm going to slide 2 times negative 9 is negative 18, and 3 on the bottom. Factors of negative 18 that make 3. 6 and negative 3. So now I'm going to write 2n squared, that's this, always gets written, and then I write these, plus 6n minus 3n, I'm expanding that out, and then I write my last term, minus 9. Now I'm going to split up and factor by grouping. So this side has an n in common, so I'm left with n. Oh, it has more than just an n. It also has a 2 in common, so 2n I'm going to take out, so I'm left with n plus 3. This side has a 3 in common, but notice how your first term's negative. You want to take out that negative 3, so now I'm left with n plus 3. Notice my parentheses match, so I know I did that correctly. If your parentheses don't match, that means you did it wrong. So n plus 3 is one answer, and my leftovers make my other factor. And I'm done. So I want you to try 8 and 9 on your own, and then come see me if you have questions. If we go ahead and we flip to the back, solving. Notice none of these problems up here had equal signs, but the problems down here did have equal signs. So solving quadratic equations means you're doing it almost the exact same way as the last page. You're just taking it one step further. So step 1, make equation equals 0. Step 2, factor, just like we did on the other side. Step 3, split up factors and solve. I cannot factor an equation if I have stuff on both sides, which is why I have to make it equal 0. So if I look at number 1, I know I have to factor because I have 2 different types of x's. I'm never going to be able to get x by itself when I have x squared and x because I can't combine them. So whenever you have 2 different types of x's, I have to solve this way. So how I solve? Make the equation equal 0. I did. Step 2, factor. So the first thing you ask yourself, is there a GCF? Does this problem have a GCF? No. Do the x method. 8 goes on the top, negative 6 goes on the bottom. Factors of 8 that make negative 6, negative 4, and negative 2. Because I didn't have a leading coefficient, I can just write x minus 4 and x minus 2. I don't have to factor the long x method. This is where I stopped on the other page. But because you have an equal sign, you have to split up your 2 factors and you have to solve the equations. X minus 4 equals 0 and x minus 2 equals 0. So x is going to equal 4 and x is going to equal 2. If I take a look at number 2, I know I have to factor this equation because I have 2 different types of x's. So first thing I'm going to do is make my equation equal 0. It is. Now I'm going to factor. I don't have a GCF, so I know I have to do the long factoring method because I have a leading coefficient. So factors of 6 that make negative 7, negative 6, and negative 1. So now I have to factor by grouping. 3x squared minus 6x minus 1x. The order of these numbers do not matter. Plus 2. Split up my factors and solve. I'm going to take out a 3x. So that's x minus 2. Over here, because my first term is negative, I'm going to take out a negative and a 1. So I'm left with x minus 2. Notice those parentheses match. That's one answer. 3x minus 1 is my other answer. I used to be done here, but I'm not because I have to have an equal 0. Split up my factors. So I'm just going to come over here because I ran out of room. X minus 2 equals 0, and 3x minus 1 equals 0. Solve for x by adding 2. X equals 2. Solve for x by adding 1 and dividing by 3. And I'm done. So I want you to go ahead and I want you to try these problems. And if you have questions, I want you to come and see.